Hello everybody, I'm beginning with the prismatic compass, and the topic I'm going to take is taking out of the fore bearing and the back bearing, and we are going to even calculate it. Ahead we will go with the calculation purpose, and we'll take out the local attraction, and probably this will go down into the next video, because over here in order to make it short, we will just deal with the readings and the tabulation sheet, in which we will be noting down the bearings of the prismatic compass. I'll be leaving few things, and when we come to the final correction mode, we'll come to it, right? So let's begin immediately. Now, what is fore bearing? There is a fore bearing and there is a back bearing. When we talk about fore bearing, it means, like, consider station A, that's the starting station. Now we are proceeding towards the next station. It is at B, so it is the fore bearing. So in other words, fore bearing refers to the direction of a line measured in the forward direction of the survey, while back bearing is the direction of the same line measured in the opposite direction. So only the direction changes. One is forward and the other is backward. So now we'll come back immediately to the figure. So here in the figure, I've taken the station as A, here as B, here as C, D, E, and again we come back to A. So this is supposed to be a closed traverse. So we are talking in terms of a traverse, and we'll go through the bearings in it as well. Now, what is a fore bearing over here? Over here, when we are moving from A to B, here, it is a fore bearing. And then when we look from B to A, it is known as a back bearing. So we can specify in this form BA. Then similarly for BC, this is a fore bearing, and CB is the back bearing. Then CD is the fore bearing and DC is the back bearing. And DE is supposed to be the fore bearing and ED is supposed to be the back bearing. Similarly, EA will be the fore bearing over here and the back bearing will be AE, and we'll have to put it down into a tabulation sheet, which I'll just show you a glimpse, and we'll be noting down the readings. So this is the first way of writing the fore bearing and the back bearing. The other way of writing the fore bearing and the back bearing is that we can write A, B, and create an arrow on top like this, meaning we are proceeding from A to B. So this will be your fore bearing, and the other one goes in this form. It goes, we write it again AB, but the direction of the arrow is pointed in the opposite direction. So it means it's a back bearing. So this is a way of writing the fore bearing and the back bearing. So now I'll wipe this out and we'll come back to the practical process, right? So now, since we have chosen our traverse, and the traverse is of course right from here, A, B, C, D and E, and again back to A, making it a close traverse. Now, first I'll let you know the reasoning for conducting this practical. The reason for conducting this practical is that we need to know these internal angles, right? These internal angles, that is angle A, angle B, angle C, D and E. Now, how much will it be? Since it's a pentagon, that means a 5-sided figure. The total should be 540 degrees for a pentagon. 540 degrees over here for a pentagon. So we will, if we are correct in our calculation, the total will come up to 540 degrees over here. So this is one reason. The other, we need to know the exterior angles. And when we talk about the exterior angles, what are they like? This is the one. This is the exterior angle over here. Here we go. The exterior angle A, the exterior angle B, the exterior angle C, D, E, and of course back to A over here. So these are the two most important angles we need. Now, what is the basic reason for doing this prismatic compass or using a prismatic compass and creating a sort of a traverse, right? For that, we will have to come back to the chaining part, where we use the chain. I don't know whether you people have used it, but in order to take out the area of an irregular land, you need to use a chain, a tape, and you need to know the angles as well. So I'll just give you a glimpse of it, and we'll come back again onto this topic so that we clarify our minds sufficiently enough, and we are able to concentrate on the mode of prismatic compass. Yes, there's one thing that have been left out, and that is the details of a prismatic compass. And as and when it's required, I'll sooner or later put down a video on it in English. The Hindi video for a prismatic compass is already uploaded on this particular YouTube itself. So let's get back to the land surveying part. Just a very short glimpse of it, right? We need to take out the area of this land, which is not a rectangle in shape. It's not a square. It's not a hexagon or a triangle. It's absolutely irregular in shape. And this sorts of lands, or similar to these conditions, you're going to come across throughout your life wherever you go in the field of engineering. So how are we going to take out the area of this particular land? Best way over here is to range this line. Now how we'll range this line? We'll add 3 pegs anywhere or ranging rods anywhere in this location. For example, as I am assuming that we have a ranging rod over here, I place a ranging rod over here, a second one around here, a third one around here, and you can have, of course, as many rods as you need, right? Now what are we going to do? We are going to distribute this area into different rectangles and pentagons, squares, triangle, or whatever is available, right? Now why did I take this line? This line needs to be a demarcation right in between. And if this line is not straight, then we will not be able to take out the other lines. And as I've shown over here, majority of the lines I've taken over here as quite straight, right? It's not necessary that it should be straight over here. They can be in curves, they can be in circles, they can be rounded up, or either way, right? So there is nothing as such that it has to be absolutely clear. Now, after arranging this line, we will distribute this line into different conditions. Let's drop a perpendicular on this line straight away. Make sure that whenever you drop a perpendicular, it is absolutely 90 degree over here, and if it's not 90 degree, then you will not be able to get the right answer. So you need to create a 90 degree everywhere. So this is a 90 degree, then over here we create a 90 degree, then let's take this point over to this point, creating a 90 degree. So now as you can see, we've got different locations over here, and we'll be easily be able to take out the readings or the area of this land. This is the first one, right? This is the second one, this is the third one, the fourth one, the fifth one. So once you take out the area of this in triangles and rectangles and pentagons, etc., you will be easily be able to add them up and you'll get the area. So now we'll come back to a prismatic compass. And in prismatic compass, we get the angles. In this case of chaining, we don't get the angles. We need sophisticated instruments, we need a level, or we need something that can take out an angle. But the chances of errors are still over there. So prismatic compass is slightly better. So now we'll fall back to the prismatic compass and we'll continue with it till the end. Here we have the forebearing of AB, and AB forebearing will be this one over here as shown in the figure, and it's been shown here as AB equal to 39 degrees and 30 minutes. And now next we'll take the back bearing of AB, and the back bearing of AB will be starting from this point and it will come back in this direction over here. So this will be equal to about 139 degrees and 00 minutes as shown right in front of you. And I'll just put down the other readings as these are supposed to be the observed readings into the figure, and we'll get back soon. So similarly, we'll have the forebearing over here, that is BC, that is 97 degrees and 30 minutes, and the back bearing, that is supposed to be this bearing over here, C towards B, that is 277 degrees and 30 minutes, and so on. Here we have CD going along, and then DC, the back bearing. Here we have DE, that's the forebearing, and ED is supposed to be the back bearing. And finally over here, EA is supposed to be the forebearing and AE is supposed to be the back bearing. So now we'll come into a tabular form for all these readings, so everything is clarified. Here we have all the observed bearings on the field, and we need to apply a bit of local attraction to finalize the reading.